All right, I'm getting lots of questions about the gas and air setup and all that, so I thought I would make a video. Jeff Colden on Facebook asked about this just today. But before I get started on that, I wanted to just mention that if you have an interest, this is a Prima China machine. You can join our Facebook group for fiber laser cutters. I've got their price list there, and you could also see other options for different manufacturers that have posted their information there. And before I get too far, this machine costs $50,000 roughly, and it can cut up to 10 millimeter or 3/8 steel. Everybody asks, that's the first thing everybody wants to know, so I want to answer it right at the beginning of the video. But I wanted to show you this real quick, a little bit about the gas setup. And if you can see this hose right here, this is where the gas is coming into the laser head, and you can see where it enters there. So the gas can either be compressed air, nitrogen, or oxygen. So, and if you look on the machine here, the way you set your cut profile up in SIP cut or SIP cut, however you say it, is you go to layer, click the layer button, and you get, you know, all these parameters. Very similar if you're familiar with plasma or other CNC machines. You can set the speed, the cut height, the lift height, you know, which is how high it lifts between cuts. And then right here you select if you want it to be gas or nitrogen high pressure. So you have a low pressure and a high pressure. And oxygen goes on low pressure, and high pressure would either be air or nitrogen. So you can select your gas there. If you select, you know, once you select that, you can select the pressure you want it to cut at. So, and this is in bar. You can also change these variables right here. If you go to global parameter, you can set what, you know, what kind of measurement you want to go with. I'm sorry, down here is where you set your unit. Like right here, if you want to see that readout in PSI instead of bar, you know, you can select that and it'll show you in PSI. So let me jog the machine back and we'll go around to the back side of the machine. And do you guys like fast jogging? So let me just jog this back up here and close the door on it. And I'll show you where the gas enters on the back, but we'll jog this thing back there at 4,000 inches a minute. Kind of scary to jog it that fast. So coming into the machine, there are two lines that feed through the cable track, two hoses for gas. And you can see they both come in right here through two holes right there. And one of these is the low pressure and one's the high pressure. I don't know which one is which, but I know one is a low pressure solenoid and one is high pressure, and you see each one's got a wire coming to it that controls it. So, and then from there it mixes, you know, it switches whichever one you've got it selected to and goes into the single one feeding the laser head. So I'm gonna get back down now. And so those hoses get routed through the cable track, and you see them exiting there, and I've got them underneath the table coming out right here. All right, so right now I've got this liquid nitrogen 4,043 cubic feet of liquid nitrogen, and I tried to use this on the gas output side, which is right here, and I tried 2 or 3 different regulators, and I finally got one that would produce more than 100 psi out of it, but it does not create enough gas pressure to run it consistently. You can get like 1 or 2 features cut on the gas side, but it immediately runs out of the gas because it's liquid in the bottom and the gas is constantly being produced, and then the gas is on top. You don't have enough gas pressure volume in there it just won't keep up with it. So you have to connect to the liquid side of this with a vaporizer and a nitrogen regulator. I am waiting. The vaporizer is available to me. I'm waiting on the nitrogen regulator that can flow the right rate and withstand the freezing. You know, the orifices and everything inside of it are made to, you know, support the liquid nitrogen. So I have, you know, the two lines. One is going to liquid nitrogen. It's actually not even hooked up right now. And so let me show you this. My air setup. I've got a this Rapid Air 3/4 inch aluminum stuff. And this is kind of a little bit on the janky side, but I've got a valve here coming into a motor guard. It's on a dryer as well. And then into this 10 millimeter quick connect push lock style fitting that will fit these hoses. So, and then the other line is coming right here to some small oxygen tanks. I had these laying around. One of them I had some TIG welding gas. It was a mix of 50-50 argon and helium for cutting thick aluminum, and I never used it, so it was almost empty. So I had it converted to oxygen, and I had another oxy fuel tank. So I've got two small oxygen tanks here, and the you know, I cut I was sharing this the other day. I cut up a job for someone that was $100 job. It had 10 pieces of like 4-inch carbon steel, 1/4 inch steel, and the best I could tell, it used about 1/4 of a tank of oxygen to cut those out. And one of these tanks is costing me $19 to get filled. So that job cost me $5 in oxygen, and it was a $100 job. So that kind of gives you, you know, some kind of scale of what you're looking at. And you can hear this nitrogen here tank is blowing down all the time. I've already had this for about 3 weeks, maybe even longer. And by the time I get my regulator, it might be empty. So I probably wasted that, but we'll see. So anyway, that is a look at the gas and air setup. Guys have talked about that. Again, you can cut carbon steel on oxygen or nitrogen up to, say, 1/4 inch. The oxygen cuts at low pressure, nitrogen cuts at high pressure. Nitrogen will give you, you can cut it faster, you can get more finite details, you have less heat affected zone, the part cuts cooler, you know, those kinds of things. You can cut aluminum and stainless only on nitrogen. You can cut all of it on compressed air, but if you're going compressed air, you have to have, really, to do it right, you need 250 to 300 PSI and 70 CFM. And your average, you know, even your big, you know, shop compressors just do not produce those kind of variables. So you need about a $20,000, $25,000 compressor and separate power pressure booster setup to get that kind of volume and pressure at the same time. If you have that, you could do all your cutting with compressed air. So I am not an expert. I'm learning as I go. You know, there's guys going to be watching this video that know way more and have way more experience than I do. I just happen to be one of the people that's sharing this information on YouTube and Facebook. For anybody out there that's looking to maybe go from plasma to laser, want to know about, you know, what's involved in it. This is a little look at the kind of gas pressures and, you know, options that you're looking at. Hopefully that helps. See you guys.